Welcome back everyone. Today we're going to go through a step-by-step guide on how to build a brushless Stryfe, RavenFire, Rapid Strike, Regulator, whatever. Now it's going to be a follow along video with the idea that anyone with no knowledge of anything can build this and it's going to work. That's with braking enabled, that's an option. The idea is that this is pretty much free, as in you download it from my Thingiverse page and you print it out. If you don't have a 3D printer, you can print it out from the page. You buy the parts, you follow the video, you put them together and you have an awesome Nerf gun. So the first thing to do is to navigate to my Thingiverse profile, and this is currently the Nerf Stryfe one, the one that we've just seen. You need to download the files. And once they have downloaded, you can extract them all somewhere. And in here are some files. You have the BL Heli configuration files for the speed controllers. You have brake and non-brake versions. That's up to you. You watch the video on brake and non-brake. Same with the Arduino code. You have a brake and the non-brake version, and that is up to you, whichever you decide. You then have some wheels, some of these, which you need to 3D print. And you also have a cage that you need to print. Now, as I said before, if you don't have a 3D printer, that's not a big deal. You can do it from the website, from here, over here, order this print. The other important thing is that it has the wiring diagram here, which I personally will be referring to while we make this. And it's good to check anything on this website as on Thingiverse. I can't update the video, I can update the Thingiverse site, so if there is a discrepancy between the video and Thingiverse, do what Thingiverse says. But it is my intention that anyone with no knowledge of Arduino or speed controllers, they can buy this, the parts, watch this video and assemble it. I've actually gone out of my way to make this as simple as possible, which is why I've used like a speed controller programmer to set them up so everything can be correct. And frankly, how are you supposed to set a speed controller up without a speed controller, because you've got a Nerf gun instead, and it just beeps and bops and it's just so painful. So I'm not going to bore you with every little solder joint and whatnot, as in I'm not going to make you watch me solder them, but we're going to do a solder and move on. So we're going to slowly piece it together. We need a Arduino to start with the parts list. We need some diodes. That is actually an optional extra for preventing it from exploding. I'll go into that a little bit more. You have to have some speed controllers, and they should be BL Heli Emax Lightning 30 amp ones. It is very important that you use these speed controllers because they need to be high frequency ones, so they're able to spin out 3000 kVA motors at full speed. If you buy cheaper ones, it will be unable to spin it at the maximum RPM, especially if we go to 4S. And we need that extra RPM because these are the wheels we've got, which have got lots of high curvature. This is the original size. Now it looks like it's bigger, which it is, but it's also smaller. The inside diameter is actually smaller on my wheels. And so we need to make sure we've got plenty of RPM. We need a buck converter, which basically takes the voltage down from the battery's input voltage and lowers it for the Arduino. Most of you will say that you don't need this. This is also an optional extra. I will definitely be using both because theoretically you don't need them for an Arduino. However, in my experience you do, and if you look on the internet you'll find people complaining that if you actually apply more than 12 volts, which we're going to be, they die. Now I realize that that will depend, depending on the weather or how you've done your hair, whether or not you'll get one that works and whether or not it doesn't. There's just countless different versions of this and different types, and we all buy them in price, so it's probably not a surprise that the cheapest ones don't actually work. However, in saying that, if you actually look at the seller's sites, it actually says 12 volts, not more than 12 volts. Even though the official documentation says up to 20 volts, the seller actually says 12 volts, so maybe if it blows up over 12 volts, that's because they already knew it couldn't sustain over 12 volts. We can see all of that, all the parts list on our information here, and you can get all the links to the parts there and updates. You need a USB programmer for the speed controller. You need a cable for programming the Arduino. There again, you don't have to make any code changes at all. You just plug it in, flash it, but we're going to go through those two applications, the one that runs this and the one that programs this as well, for people that don't know how to do any of those things. And really it is as easy as double clicking and clicking next. Well, it should be, but it might not be. Now that I've said it's that easy, it probably won't be. You obviously need some way of connecting this to your LiPo battery, and you need some wire, which you can all get. You can get crazy massive wire. There is no point in it really, because the wire on the motors is tiny anyway. So, as I said, we're going to go through this together. We're going to start with the Arduino somewhere. What have I done with it? I've lost it. Did I eat it? Here it is here. And that's just torn badly, now I can't get into it. So we're going to start with applying power to it. So that is at ground and V in, which means we need our diode, which has a silver line on it. Need to make sure we get that the right way around, and I'm pretty sure I know which way around to do it, but since I'm on the video I will get it wrong and it looks like a complete muppet. So the silver line needs to be going towards V in, which is too hard for you to see. Something like that. Now the purpose of this is that when you connect this all up to your buck and your speed controllers, unfortunately the Arduino is not diode protected, and that's why we have to add that diode. Well, theoretically you don't need it. However, in my experience, that's how you destroy Arduinos endlessly, is by accidentally blowing them up. And how that happens is that you plug in your Arduino, your innocent Arduino, you plug it in, and you think, oh, it's time to program my Arduino. You plug this end into your computer, and because you've got a speed controller and you've got your buck converter all connected to the battery in voltage, like here if you like, and over here we've got our motors and whatnot. What happens as soon as you plug this into the computer, electricity will flow from your computer up the cable into the Arduino, power the Arduino, and then go, there's nothing preventing me from powering the speed controller. There's nothing preventing me from powering the motors. Hang on. Oh, computers died as well. So that's why we have the diode. Now technically you don't need it. That only happens, what I've just said, is if you ever plug in your Arduino to program it and you haven't plugged in the LiPo. If you've plugged in the LiPo and you plug it into your computer, it'll be fine because the speed controllers will be able to gain their power from the LiPo, so you don't actually need this diode there. However, I put it on because I mistakenly blow it up, and it's painful having built it all, put it all together and flashed and go, oh, I've just wrecked my computer. Although that hasn't actually happened to my computer, but I have toasted many Arduinos by not having a diode on the input voltage. But for the purists out there, you do not need that. However, we're trying to build a simple circuit that works for everyone and doesn't cause fires and crying. So I'm going to solder that on, and then we shall keep going. Okay, that is now soldered onto VIN. Just put it through and soldered it from the back, cut it off. We then need to add in our buck converter. Now annoyingly, this one has been incorrectly labeled with 2 outs, minus outs. This one should be, closest to my thumb, should be a positive out, and therefore that should go through our to positive and pop it through there, and then our negative out should go to our ground. So I'll do that now. Okay, there we go. Pretty sweet. This particular one is adjustable. The one I'm currently recommending is fixed at 9 volts, so you don't need a voltmeter to change that. That's why I did it, to make it life simple. Right now I need a voltmeter to set that and obviously apply input voltage. So I'm going to solder on a positive and a negative line. That is going to go to the battery. So I'll do that now. Okay, I've wired everything up. Now I have powered it into my bench power supply. You can use that on your LiPo. I highly recommend that after every major stage you test to see if it catches on fire or not. If you're not very good with your soldering, this can catch on fire. Not literally, but well, I've actually seen like it go red. And if you do have a couple of times and you've burned out a few of these and you can't get it right, it possibly get a board with this soldered onto it, and then you can just solder onto the large pins, which basically is impossible to stuff up. Right, so let's turn it on, see if it works. Sure, it works. Stuff happens. So that's cool. Can't really tell if it's doing anything, except for it hasn't caught on fire. Okay, well, we can move on to the next stage. Okay, we need to download the Arduino IDE, which is basically the application, the UI for programming. I'm not sure which one to use. I guess we'll go for 1.8.2, so download that. Make a contribution. It will download, and once it's downloaded and installed, you need to plug in your Arduino, which you have powered with your LiPo or whatever. You can plug it in without any fear of your whole world exploding. Go to our downloads, go to the files. You now need to decide if you're going to have braking enabled or not enabled. I've got a video on that, watch that. We're going to do braking because I like it. You don't have to if you don't want to. You should have to just then double click on the code. It should complain about not having a folder, I believe. Blah blah blah, yes, make a folder. Okay, here is the code. You do not need to change anything on the code. All we need to do is plug in Arduino, and we need to make sure that it's set to the right board, which It is not. It's a nano. We need to, it's always a 328 in this day and age. Set the port. In this case it is pretty easy. We've only got one port that it can be, I hope. Then you click on this button here and it should work. It's now doing it. It'll come up with errors down here if it didn't work, and the error may be because you plugged into the wrong COM port, so try that. Right, it's done. So now, in theory, our board is now programmed and we can move on to the next stage. If you have a problem like this where you can't program the Arduino, it just sits on here uploading for ages and then gives a crazy error like this, it's probably got the wrong driver, because you probably bought a cheap Arduino, because they all seem to be cheap. There is a video on how to resolve that, which I will link to now. Okay, now we have our target blaster, which is going to be a Rayven this time. Son loves this. It's the old as the hills. I actually do like it. I think it's got a better feel, and the spring can be very soft on it, which you can't on the Stryfe. Anyway, this has just come out as a RavenFire. So we need to now connect up the switch to the Arduino. I can never decide how to say that. Now you'll find that it has 3 pins. Firstly, it's perfectly fine to use the original switches because this passes no current, and if you have replaced it with a massive switch you can use that as well. That's fine. The question then becomes which one of the 3 to use, and the easiest thing to do is to use a multimeter to figure that one out, but you don't need a multimeter. You can do it and take a wild guess, and if you get it wrong you can just change it. And luckily the Arduino will tell you whether or not you got it wrong, because I tried to make this easy for you guys. So at a guess, I guess it's going to be the middle one and the bottom one. And if we push, okay, it is doing, oh, hang on, now it's not doing anything. When I push that, it explodes. Yeah, it pushes down the button. And that's what we want. That's the middle and the bottom one. And we'll go and solder on some wires from the middle one and the bottom one. Okay, I've done that now. So I'll screw that back on. Okay, now you are left with 2 white wires. Now I intentionally made them the same colors just to confuse you. No, the reason why I made them the same color is because it doesn't matter which way you solder them on. You need to at this point decide where you're going to put your Arduino and your battery and whatnot. I would normally put it in the original battery cage, but at this point I think I've decided to put it in this massive space here, because I do currently have my LiPo on this side anyway going into here. So I think that'll be easiest, but I might regret that. Haven't really thought this through. Okay, so these 2 wires go on to ground and D2, which is ground and D2, where my fingernail is. Solder those 2 on, then we can test it out. Always remember to turn that thing off and solder those on. Okay, so we've now soldered that onto ground and D2. We'll power it up. Okay, if all goes well, when we pull the trigger, this L, or the light, will come on. Hooray, it did. If it doesn't come on, throw it away and use another Arduino. That's great. So all we have to do now is wire up the motors and obviously put them in the cage, because it ain't going to go very well without those. So I'll move on to that next. Okay, now we need to put the motors in. This one's always weird because it's like back to front. Right, the black one I believe is in the cap, which I think is the counterclockwise one, I believe. Whoops. Should be in the bottom. Oh, it's really complicated to figure out. Because the screw goes the other way around too. Something like that. Now, you'll notice that in the bottom of these, you've got this black thing here and it has two wires. You may find that that is blocking some of these holes. So then you have to use the short screws. Otherwise, you can use the long screws. So I'll go ahead and screw those up. Okay. We then need to solder these guys up. And then we can get programming. So what I think I'm going to do is it makes a lot more sense to put all of this stuff over here somehow in this massive space than over here, because then I only have to run the power wires from here to here because everything's already over here anyway. So I've made that change on the fly. That then makes these white lines probably too long, but everything else shorter. So I will solder these wires coming from here and these guys into something I can plug my battery in to, which is different. It's one of these ones. So I'll do that now. Okay, so I've soldered on extra long wires and shrink wrapped them, obviously. And they're going to run all the way down here and out here. And they're going to go through the battery container, which comes on this side here. The power and Arduino I've spliced in here. I've done the same to the other side, but in the join between the speed controller, which is over here, goes underneath and around there, we just added in the power from our buck converter. Let's see if we can just pull that all out. So something like that. So I'm going to run two separate power leads to the battery. I always find that easier to wire, and it's a bit better electrically. This wire I'm using is a bit small, but that's all I had. I didn't actually have enough of the bigger stuff, but since I'm going to run one line per speed controller, it'll be just fine. So now I need to solder on one of these on this end, and then we must be up to programming the speed controller. Okay, I've soldered that up nicely. Well, that's nicely for me. One line for each ESC. And the other one goes over to here. Well, goes over to here to the other speed controller, as well as to powering the Arduino. Of course, it's not working because it's got no power, so let's plug some power into that. Okay, we have power. See if it still works. Yes, our magical light comes on. We're now going to move on to programming the ESCs. Okay, so you will find, annoyingly, the ESC has two lines. One is negative, and one is the signal, or the pulse. Now, of course, the ESC manufacturer does not tell you which way around to plug it in, and there's nothing preventing you from plugging it into the programmer the wrong way around. I don't know what will happen if you plug it in the wrong way around. I got it right the first time. It may explode, and knowing my luck, it probably would explode if I plugged it in the wrong way around. So I have taken the, goes this way around. Oh gee, that's the wrong way around, isn't it? Okay, that way around. Negative, positive signal. You'll find this has only got two lines. That's because this doesn't have BEC out or power out of the ESC. The extremely high performance ones that I found didn't have BSC out. You could get them. They cost a lot more, and then people would probably complain about that. It then also did create a problem if you were to put a diode in there, because for a start the BSC is 5 volts out, so you couldn't plug that into the V in on the Arduino, which requires 6 volts. If you plugged it into the 5 volts in, because of the diode, that would reduce the voltage and it would still have problems. So I haven't done that. I've done it this way because I want it reliable and I wanted small affordable ESCs. Now these are extremely high frequency ESCs. They are required to spin these motors at 3 RPM, which are 3000 kV motors, which is not high as far as motors go, but is very, very high because they have very high pole counts, which is what really matters. And since we're talking about ultimate performance, we need all the RPM we can get, because there again the inside diameter is smaller. And hey, we're trying to make something super awesome, not something meh. So if you use cheap ESCs, which people have done, you will theoretically get less RPM and therefore start defeating the point of this whole project. So that was a bit of a rant. So brown is actually negative and yellow is signal. So plug that into there, like that. Then plug this into your computer and hope it doesn't catch on fire, which it didn't. We then download the BL Heli suite, which I just went to the first one on the page, which takes you to this random WordPress page, which then takes you to a megafile download. I think it's megafile. Yeah. There are more than one different versions of the suite, therefore different processors running on the speed controller. That's for a 32-bit one. Don't download that one. I've pre-downloaded it. I'll obviously chuck that link on. Once you've downloaded it and you run it, you'll get an interface like this. You need to select the right connection method, which is a USB COM, and obviously select the right USB port, which is going to be this bottom thing down here, and connect. That didn't work, did it? Right, that worked. Okay, you can now read the setup from the ESC, which will show you available options. Now I've already programmed this, I think. The first thing to do is to flash the BL Heli, which basically is to make sure you flash this to the latest revision. This has already been done, but pretty much click this and go yes. Even though these are 30 amp ones, it's the same code, so it's the 20 amp. It's fine. Blah blah blah, the world's going to come to an end. Flash it. It's important to flash it because there has been revisions which has improved top-end performance and whatnot. And we're talking about top-end performance here. We're taking these ESCs to the absolute limit and the motors to the absolute limit. So we need to make sure that we're all good. Do you want to write that? You just can write the preloaded settings back to it, though there's no point. Now, instead of having to faff around with all of these settings, you can now load the ini file. So read the setup ini file, and that should be from, I don't know, downloads. I think we had it where we downloaded all of our code from the Thingiverse site. Now you have to flash it with the same code that you decided to at the beginning with flashing the Arduino. As in the Arduino we decided to flash it with the brake software, so we need to flash it with the brake version of BL Heli. Go OK, and then you can write the setup. Now if you don't do this, you'll have motor timings wrong, and you'll have where the ESC detects the trigger being pulled at the wrong place potentially. This makes life really, really easy. You just flash it with the settings I've already got, and Bob's your uncle, you're done. I don't think anyone's used that saying ever, have they? I've just alienated heaps of people. Except for the people that have Bob as an uncle, I guess. Now that's it. You can then disconnect it and perform the same to the other ESC, which is going to be a bit hard. Let's bring it all closer. Oh, I almost plugged that in the wrong way around. Okay. Read setup. Cool. Flash it to the latest version. Yep. Yep. Just another reason why I specifically chose these ESCs is because they were fully supported by the BLHeli application and the dongle to make our lives simple. Read it from the setup. Break version. Yes sir. Right setup. Oh yeah, that's because I've already flashed this before, so it was the same. And disconnect it. And we have done it. That is the fastest way you can possibly set up an ESC. And there's no way you can definitely flash that, as in update the revision, without using a USB link like that. There are more complicated ways of doing this. You can actually use an Arduino instead of that, but this is a few dollars. Makes life easy. So we are almost at the point of being done. We've just pretty much got to solder up to the motors, and we should be done. So I'm going to solder that on. Well, I'm going to solder one on, and then we'll come back. Okay, so I have soldered up one motor and one ESC. You will find that there are 3 wires going from the motor connecting to the speed controller. Your first question will be, how on earth do I just know which way to solder them up? And that is an annoying answer. But I guess it's not that bad. Expensive speed controllers and motors will have them normally labeled ABC. That is not it in our world. So you pretty much just solder all 3 on, test it, and if you get it wrong, then you need to change 2 of the 3 wires. It doesn't matter which of the 2 of the 3, just swap them round. Obviously for us we need one motor going this way and one motor going this way to push our dart through it. So what I'm going to do now is I'm going to solder up the ESC. Oh, actually I'll solder up both motors, one on each side. But what I was going to show you is how do you know that things are kind of working. So it makes this noise. Now when you have 2 ESCs and 2 motors plugged in, it's a bit of a racket and slightly out of time. Now hopefully you heard that. Let me bring that closer. Just that. Not a double one, it's just a single. Okay, that means that the ESC has power, but it doesn't have a signal from the servo controller or the Arduino. So that's a good thing to know when you're talking about troubleshooting it. If it just makes that noise, then you know it's lost a signal from the Arduino. But of course there'll be 2 of them, so it'll play the same tune but slightly out of time. And when we have the full signal, it'll play that noise and then a bit of a gap and then another bit of a noise, and then you know you're all good to go. And there's quite a huge delay between that, but I shall show you. Okay, let's solder up that other ESC. Okay, and so this is what it sounds like now with 2 of them plugged in. And that's it. Okay, we're almost on the home run. We now have to solder up the speed controllers to the Arduino to give them life. Now if we take that back out of there, we need to solder onto D9 and D7. Yellow going to D9 and brown going to D7. Both of them simultaneously, so I cut these off and I solder one to the top of it and one to the bottom of it. It seems to be the easiest way. Or maybe I'll get them both through the top on this one actually. Twist them together, put them through and then solder them on. And that will hopefully be us. Seems hard to believe, doesn't it? Well, the chance of us doing these motor wires correctly is unlikely. Now I actually haven't done a good job soldering them. That's intentional because I believe it's unlikely I would have magically got it right. But let's find out. Okay, now soldered up our ESCs. Now you'll notice that this is actually different. I've soldered it from the bottom instead of from the top. It died. And interestingly enough, I wonder if it's actually the flux that's creating the problem. There's a lot of traces around the bottom. Well, there seems to be. I don't know if that is. Yeah, I think it's so easy to actually bridge to the outer ring, which then you come along the second one and bridge to the outer ring, and boom, she's gone. So I'm actually not going to recommend using these ones. Maybe we'll go back to the ones with the raised pins. They're really, I've never had problems soldering onto those, and I do want this to be successful, and I keep destroying these things. So even before I said that, I actually ordered the ones with the posts, and you can just cut the posts off that you don't use, or bend them over or whatever. Probably bending them over is a bad idea. But of course you can do it this way. I think it's easier this way because there's a little bit more nothingness around the holes. But in any case, I have soldered it up, given it power, and if we apply trigger, it works. However, I have managed to, of course, I think I've got it the wrong way around. I managed to get both the wrong way around. Ah, what a fail. So, what I need to do now is unsolder two of each of the wires on the going to the motors from the ESC and swap them round. Just two of them, and then I'll do that for both of them, and then it'll be right. And we're done. Okay, well, I have turned everything around, and now we are going the right way. I think it just sounds cool. Alrighty, so now we have to put the wheels on, which I don't think actually fit on. I have to take it all apart and unscrew those to put them on, and then we'll see how we go. A special note on the wheels, the force is not supposed to be applied around the center hole. That's actually much bigger. Okay, it's supposed to be on the outside housing and therefore the inside of the wheel. So you need to make sure there's no debris on the inside of the wheel, because that'll throw it off of being round. And it's supposed to be a tight fit. If it's not a tight fit, then it will have problems. So it needs to be a tight fit. And interestingly enough, even though I've made them all the same size, sometimes when I print them, they're slightly over and slightly under. But it is important that they fit on, and ideally so tight that you actually have to use the screwdriver socket and the nut to hold them on down. And you'll find that if it's not tight enough, you won't be able to do this nut up because you won't be able to prevent the motor from spinning. But if you are having that problem of spinning, you can put it on the table, push it down, you should be able to get it up, tightened up. So that looks pretty sweet in my opinion. Looks hot awesome. Ooh, and it even works. Should we fire it up? Yeah. I haven't fired this up before. Sorry, I forgot. We have to wait for the second set of beeps to go through, which signals that it has not only power to the ESCs, but also a signal from the Arduino. Okay, let's have a look at that. See if I can put one through. Well, that seems pretty good to me. All right. Let's put that all together. We're done. Woohoo! Would you believe it? An hour later, and we're done. Wow. Just going to put some insulation over everything and put it back together again. Okay, so this is where I'm at. I ended up routing the cables down here. The obvious place of going underneath the cage was just too risky because the wheels stick out. And I was just going to wear out the power cables and cause a fire, so I've gone this way around instead. I did cut this down a bit more to fit the cables under there. Should work. Managed to find all the missing parts. Stoked. Right, let's put it back together again and see how she rolls, baby. Yeah. Okay, well, it's done. And fully ready to go. It's got some really old destroyed Elite darts in it. It's certainly very loud. Yeah. Be interesting. It's I've chronoed it. It's pretty quick to maybe being the quickest one around at the moment. Single flywheels, of course, although they don't seem to have published numbers very easily for modified ones. However, if you have made it thus far to about an hour's worth of video, I would like to congratulate you, and I feel maybe you could give me a like. I'm going to check the stats on this video and see how many people make it to the end. I think it'll be really low. It'll be interesting. Well, I certainly hope that you guys have managed to make it thus far, and hopefully you've been able to replicate it. That was the whole point, is to be able to make super awesome Nerf guns. Now I know these, well, at least the Stryfe looks like it's in disarray. That's because that's still a work in progress. But they are certainly... Oh. Stop halfway through a sentence. Certainly scary. Need some dart dust on that one. I'm not really sure why it's so loud. I think it vibrates badly in this one, I think. But it has the fare. It creates the... Oh, what the heck is that? Alright, guys. I'll see you on the next one, maybe. That was a mammoth making and editing and cutting. See you later. Bye-bye.